Hello there, creators. Welcome to the third lesson of momentum and impulse. So today we are looking at the law of conservation of momentum. Right. So now you need to understand what does conservation means. Now it will mean that for something to be conserved, it must not lose its form. Right. So if something is conserved, meaning that it stays in its form. Right. Okay. So let me just put that note: stay in form, or does not change form. Right. Okay. So now let us look at the law of conservation of momentum. So as I always ask you guys, please make sure that you have your examination guideline next to you when following through with this lesson. Right. So now your law of conservation of momentum. Now, what is the law, or what does the law of conservation of momentum say? So the law of conservation of momentum simply tells us that the total linear momentum, right? The total linear momentum in an isolated system. What happens with the total linear momentum in an isolated system? It remains constant. So now would ask himself, now what is this thing of isolated system? So now an isolated system, we are talking about when there are no external forces, right? So there are no external forces acting on object, right? Or the correct term to say is that it's when the resultant external forces acting on the object are equals to zero, right? So that's another way in which you can put this thing. So you'd agree with me that if there are no external forces, then what would change this momentum, right? So nothing will change this momentum because there's no other force that is acting, or no external force that is acting there to disturb this momentum that we have. Then now it follows that when we have linear momentum in an isolated system, that the sum of the momentum initially would be equals to the sum of the momentum final, right? So now this expands and goes on to say, right, if we have object 1 and object 2, so the mass times the velocity of object 1 initially plus the mass and velocity of object 2 initially, that would be equals to what? To the mass of the first object finally plus the mass of the second object and velocity of the second object finally. Right. So now this is the formula that shows the law of conservation of momentum. Right. So usually when they ask you definitions in physics, it follows that you might use that formula. Please listen clearly. You might. Sometimes you might use it in the second question, sometimes in the first question that follows, right? But in a way, you might end up applying those principles of the definition you're being asked, right? So take note there, might and not always, right? Okay, don't be cramming, but understand. Okay, right. So this would still represent your mass, this would still represent your velocity, and yes, so this is as simple as what the law of conservation of momentum is all about, right? So there are three possible scenarios that we might get, or even more, right? So the first thing is when we have two separate objects that move towards each other and they collide. So at first we have two objects initially, right? Then they collide. Then after colliding, they bounce of each other and what they move away. So in such a situation, you would use this formula right here, right, as it is. So you have two objects that they collide. So they come and collide. So after colliding, they move separately, right? So this is the situation that I'm trying to explain here, right? So in the type of situation, the second type of situation, we'd have two separate objects moving and colliding with each other. Then after they collide, they now combine. So this is the type of a situation I'm talking about. They're coming off separately, they come and collide. Then now after colliding, it will depend now which one has a greater momentum on which direction. So let's say it has a greater momentum going to the left. So now they will be moving together with each other. So please excuse this. I'm trying to explain a situation here where they are together now. So maybe they are moving now in one direction. So in a situation like this, the second situation I'm talking about, you can use the formula here to say it's going to be M1V1 initial plus M2V2 initially would be equals to what? M1 plus M2 times V. So you'd see that this is still the same formula, but I'm just trying to make you understand that now the masses would be added together because they are now moving together, right? Okay, so now that is the reasoning behind this formula being written like this. Right, okay, so in the second situation, you just simply add the two masses and multiply by the same velocity because they'll be having the same velocity, right? So the third type of situation would have two objects that starts as one, then after maybe an explosion or a collision, they now move separately. So maybe you'd see that, okay, they start off like this. Then now, maybe after a collision or explosion, so this is what happens initially. Then after an explosion, they now move separately, right? So this one would be going that side, and this one would be going to the other side, right? So in that case, what do? You add the masses initially, right? V initial will be equals to, then on the second scenario, you now separate them. So that would be VI final plus M2 V2 final, right? I hope that this makes sense, right? So now that is simply what the change or the law of conservation of momentum is all about. So it's all about you looking at, okay, what happened? So for you to recognize the event that happened initially, you would need to look, okay, before there was a change, the change would be the what? The collision, or it will be the what? The explosion. So it would mean that what separates the initial and the final would be that explosion or collision, right? So that is how you differentiate between the two events. So please make sure that you don't mix up the two. So I'll try and have examples going forth so that you try and comprehend what is happening here, right? Okay, so join me for the next lesson. We are now going to be tackling impulse, right? So please make sure that, guys, you do share this video so that others also get the same help that you are getting, if you are getting help, right? Okay, so thank you very much. I hope that you guys will subscribe to our YouTube channel. You will follow us on TikTok, on Facebook, everywhere on our social media platforms. Please make sure you engage with us, and if there's anything that you need, please make sure to write that in the comment section. Thank you very much.